We're going to finish up our look at probability by talking about expected value. Our objective in this video is rather straightforward. We want to simply compute the expected value, and it's going to be for one situation that involves rolling a six-sided die. What do we come in knowing? Well, as usual, we know what probability is, the chance that something, an event, will happen. It's always between 0 and 1. Or in percentage terms, it's always between 0% and 100%. And we know how to find the probability of an event happening. Our denominator is the total number of outcomes. Our numerator is the number of ways the event can happen. Okay, let's define what expected value is. I'll shift up here for you. Expected value is the long run average. What happens if you do the same thing over and over and over again? What can you expect the average to be? Okay? So it's a mathematical way to use probabilities to determine what to expect in various situations over the long run. Okay, where is it used? Well, it's used to determine insurance premiums, risks and benefits of alternatives in business ventures, and to calculate what will happen in games of chance, for example, gambling or lotteries, again, over the long run. And this is just some of the examples here. Okay, to find it, okay, we're going to call expected value E, and we're going to multiply each possible outcome by its probability. And then we're going to add up all of these products to get our expected value. Okay, let's take a look at the example I mentioned, which is rolling a six-sided die. Okay, so find the expected value of rolling a die many times. I probably should have said six-sided here. We're talking about a regular die. That's a regular six-sided die. In other words, what is the average, or what will be the average of all the numbers when you roll many, many times? If you just keep rolling it and you add up the numbers you roll and divide by the number of rolls, what's the average going to be? Okay, so let's take a look here. Again, we come up to here, outcomes by probability. So I have a chart here, outcomes and probabilities. Well, you roll a die and you have six possible outcomes. You can roll a 1, you could roll a 2, a 3, a 4, a 5, or a 6. Those are all the outcomes. And we always want to discuss or talk about all possible outcomes of what can happen. Okay, now, what is the probability of each of these outcomes? Well, the probability of rolling a 1. Well, there are 6 total outcomes, six-sided die, and one of those is a 1. So the probability of rolling a 1 is 1 out of 6, or 1/6. Okay, what's the probability of rolling a 2? Same. There are 6 outcomes, and one of those is a 2, so you have a 1 in 6 chance of rolling a 2. And as you know, I'm sure, it is the exact same for all 6 of these outcomes. There's a 1 out of 6 possibility of rolling each of these. Now I want you to notice, if I add up all of my probabilities, the total equals 1, or in percentage terms, the total equals 100%. We want to account for all possibilities, so the sum of these probabilities is always going to be 1. Okay? Now let's do the math. To find the expected value, which we're calling E, multiply each possible outcome by its probability. 1 times 1/6, 2 times 1/6, 3 times 1/6, etc. And then add these products. We're going to have 6 products, and we're going to add them up. Okay, how does that look mathematically as a mathematical sentence? The expected value is going to equal 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6. Thank goodness it's only a 4-sided die. 4 times 1/6 plus 5 times 1/6 plus 6 times 1/6. Okay, so multiply each outcome by its probability and then add up all of these products. This is a calculation. Pull out a calculator, and the answer comes out to be 3.5. Okay, so what this is saying is the more and more you roll, you're going to wind up seeing an average of all those rolls of 3.5. Okay, not just one roll, not just two rolls, but the long-term average. Doing this over and over and over again, this will be what it averages out to be as you look at all the numbers and divide by the number of rolls. Let's put that down in words here. As you continue to roll the die many times, okay, the average of the outcomes, the average of the rolls, okay, so we add up all the rolls and we divide by the number of times we rolled, will be 3.5. Okay, so that's expected value in a nutshell. We're next going to look at a video to see this in business applications, and then we'll take a look at gambling or games of chance applications.